Hi guys, today we are going to be solving this problem. Find all possible recipes from given supply. This is the B problem of Leetcode Biweekly Contest 68, which has just ended at 9:30. So I'm sure like this problem has frustrated a lot of you, and I agree, it frustrated me also. So we'll talk about why it was giving TLE. Like you can see here, only 1500 people have got accepted, but the total number of submissions are above 10,000, right? So you can understand, like on an average one person submitted from 9 to 10 submissions, so you can understand how frustrating this question was. Okay, so first of all, let's understand the question, and then we'll see how I solved it. So you have information about n different recipes. You're given a string array recipes and a 2D string array ingredients. Okay, the ith recipe has name recipes of I, and you can create it if you have all the needed ingredients from ingredients of I. Okay, so for every ith recipe, the ingredients needed to create recipe of I is given in ingredients of I. Okay, also ingredients to a recipe may need to be created from other recipes. That is like it can be the case like to prepare some recipe X, you need recipe Y. Okay, yeah, and recipe Y has to be created. It is not given in to you in the starting. Okay, so it may contain a string that is in recipes, and you are also given a string array supplies, the initial supplies of ingredients that you are going to have, and you have infinite supplies of all of them. Okay, so we need to return a list of recipes that you can create. You may return the answer in any order. Okay, and they have also said that two recipes may contain each other in their ingredients already. Okay, 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 so let's go through this example first. So here we are only given one recipe, which is bread. We are given the ingredients yeast and flour. That means to prepare bread we need two ingredients. One is yeast and the second one is flour. And we are also given the supplies, the initial supplies that we have the infinite supply of yeast, infinite supplies of flour and corn, right? So since to prepare bread we only need yeast and flour, and they are available to us initially in the supplies array, that means that we can create bread without any problem, right? So we can create bread, and since the number of recipes was only one, so the answer comes out to be bread. Now here in the second example, they have added sandwich into the recipes list also, right? And in the ingredients for sandwich, we need bread and meat. Okay, and in the supplies we have the same supplies, yeast, flour. Okay, no different. Here it was corn, here it is meat, right? So one thing that you can notice from here is that to prepare sandwich I need bread, and bread is not available in the supplies, right? So initially, like my first dish that I am going to prepare, that cannot be sandwich because I do not have all the supplies needed for it, right? So what I'll do is I will try to find out the first recipe for which I have all the supplies available, right? So here I come, I see bread. For bread I only need yeast and flour, and yeast and flour are available to me, right? So first of all I'll prepare bread, right? So now bread will also be added into my supplies array. So now right now I have uh, four elements in my supplies array: yeast, flour, meat and bread. Now I go to the sandwich. Now sandwich needs bread and meat to be prepared, right? Now meat was already given to us initially, and we have prepared bread in the previous step. So both of these ingredients are available to us as supplies, right? So we can also prepare sandwich. So the answer comes out to be bread and sandwich. And if you apply the same logic, you will see that all three recipes are can be prepared in this example also, right? So now look at the constants. Okay. Hmm. So the length of, so n here, the number of recipes can be 100, and the length of the ingredients needed by any n, that means like the number of ingredients needed by any recipe is also lesser than equal to 100, and the length of the supplies is also lesser than equal to 100. So for the worst case, for analysis or the worst case, we'll try them both as 100. Okay. And it is also given that recipes of I dot length, ingredients of ij dot length, and supplies of k dot length is lesser than equal to 10. That is, every string that is going to be present in recipes array or ingredients array or supplies array, its size is going to be lesser than equal to 10. And they consist of lowercase English letters. All the values of recipes and supplies combined are unique. Each ingredient of I does not contain any duplicate value. All right. Okay, so first, when you see this constraints, and also it was a B problem, so you straight away want to go for the brute force solution. And I agree with you. I did the same, right? I went with the brute force solution. So what was the brute force solution? First of all, I took all the initially available material to me in a map. That is, I made MP of I equal to 1 for every item in supplies, right? So that I at every time, if I have to check whether I have this current element, you can say current ingredients in my supplies or not, I do not have to go over the entire supplies array. I can just check that whether MP of the ingredient that I want to check is 1 or not, right? Okay, then I initialized a vector string answer, and then I did int n equal to recipes of size vector in possible. This pose is going to represent whether I have made recipe of I or not. If the value is 0, that means recipe of I has not been made. If the value of pose of I is 1, that means I have already prepared recipe of I, so it has converted into my supplies, the current supplies that I have, right? And also I have initialized an integer previous equal to n. This will tell me the number of uh, recipes that were not prepared in the previous cycle. You will see its use in a bit. Okay, so then what I do is I start a loop while 1, and before doing my processing, I check whether uh, at least one recipe is there which has not been prepared, right? If I have prepared all of the n recipes, then there is no sense to do my processing, right? So here I am just using a map, and I am checking whether the position of I possible of I is equal to 0 for any recipe. If it is 0, that means that recipe has not been prepared. So what I do is I make my flag as 1. That means, yeah, I have to do the processing. So here, if flag is 0, I break, otherwise I keep on doing my processing. So what I do is I iterate over all of the recipes in my array, and I check if pose of I is 1. Pose of I equal to 1, why I'm checking is this, that means this recipe has already been prepared. That means it is already available in my answer. I have already added it to my answer, right? So I do not want to add any recipe twice, right? So if it has been already prepared, I just continue. Then I make f equal to 1. You will see why. Okay, so then what I do is uh, I iterate over all of the ingredients needed to prepare this current recipe, that is recipe I. Then I check whether the current ingredient on which I am, that is ingredients of I comma j, whether that is in my supplies or not. If it is in my supply, then the value for this key is going to be 1. But if it is 0, right, not 0, sorry, if it is 0, right, then I'll make my f equal to 0, which means I cannot prepare recipe I at this time. It may be possible that I am able to prepare this recipe in the future, but for the current time I cannot prepare it, right? So I'll just make f equal to 0 and I will break, right? Then I'll come here, I'll check if my f is equal to 1. That means, can I prepare this recipe I or not? If I can prepare, then this will convert into my supplies, right? So I'll make a map of recipes of I equal to 1, and I will also push this recipes of I in my answer vector, and I'll make possible of I equal to 1. That means it has already been prepared, right? After that, what I will do is after this loop has finished, right, what I will do is I will count the number of recipes that are not possible, right? And then I will check the number of recipes that are not possible to make with the number of recipes that were not possible to make in the previous cycle, right? And this value is held with the previous. Now suppose I was not able to make 4 recipes in my previous cycle, right? So my prev is going to contain 4. Now after doing all my processing in this cycle, again I'm not able to make 4 recipes, right? That means I will never be able to make any any recipes after it, because I have already created all of the remaining. Suppose and there were n recipes, so I have already created n minus 4 recipes, and 4 recipes are remaining, and I am not able to prepare them in 2 consecutive cycles. That means that they can never be prepared, right? Their needs can never be fulfilled. So there is no sense in again and again processing this loop. So if count becomes equal to prev, I'll just come out of the loop, right? I have already got my answer in the answer vector. But if count is not equal to prev, that means count has decreased. Count can never increase, right? You're seeing this, I hope. So I will make previous equal to count, because this current cycle will become the previous cycle for the next cycle, right? And I will keep doing this. Okay. And at the end, I will just return answer. Okay. So most of you would have done this, right? This was a very easy part. And if you had done this, so like if you go to submit it, uh, it will give the correct answer here, but when you submit it, it will give time limit exceeded, right? Yeah. Now how to fight this was like the biggest challenge, I think, in this problem. There was nothing so difficult except just finding out how to remove this time limit exceeded. And there is a simple technique to do that. Here what we are doing is we are copying every ingredient uh, in J string, right? Auto, I'm using auto here. That means this J is going to be string type, and I'm copying every ingredient of I whose maximum length can be 10 into J, right? So that operation is unnecessary because I'm not changing ingredients of ij anywhere in the future, right? So instead of copying the string into it and adding that constant into the time complexity, what I can do is I can just take this as reference. That means this current string, this current ingredients of ij will not be copied, but a reference will be passed. And when a reference is passed, the time complexity is constant. Uh, it is not greater like when you're copying a string, right? So the time complexity is going to be order of the length of the string, right? O of, if length is like if length of the string is len, the time complexity is also going to be O of len for copying, right? But if you're not copying, if you're passing the reference, then the time complexity is going to be O of 1, right? Here I save some time, a constant time, right? A factor of 10, and that factor of 10 will make the entire difference here. You can see what? Okay, okay, this got accepted, right? Leetcode is high, I think. Yeah, this could, I don't know what it is doing. I think it is high. Okay, so here I am able to save some time because of taking my string, my ingredients of ij is reference. I do not know what Leetcode is doing. Okay, so yeah, so okay, and let's look at the time complexity of this approach first. uh, this loop, let's start from here, right? So this loop is going to run for a maximum of n time. We are taking n as 100, and we are just considering the worst case, right? So here the hash value is going to be calculated, right? So the length of the j, that is the length of the string, can be 10, right? So it will be run over 10 times. We have to take in consideration the constant. Here if I was not using this j, right? If I was not using this j, let's say if I was not using, right? So what would happen is, first of all, this loop will run O of n times because there are n ingredients for current recipe I. Plus this copying will happen for every ingredients of I, right? So the time complexity will be O of n, where the maximum value of n is 100, so I'm taking 100, into the maximum length of ingredients of ij is 10, so O of 10. And since in every iteration I am doing this much work, so it would be 1 multiplied also, so it would become O of 10 raised to power 4. Okay, yeah. Now let's come back here. This loop is just going to run O of n times. It's plain, right? So it is O of 100 multiplied by, in every iteration this much amount of work is going to be done, right? So 10 raised to power 4. So it becomes O of 10 raised to power 6, right? This loop is also going to run O of n times, so we don't have to worry about this, right? Because we are talking about the asymptotic case. This loop is also going to run O of n times. You don't have to worry about that because we have worried about the loop that is running for more than the twice, more than this, right? And same for this is constant, and this is constant. Yeah. Okay. Now, how many times is this while loop going to run? Think carefully, right? This is not an infinite loop, right? This while loop, like maximum times it is going to run for O of n. Why I am saying this? Because as soon as like all my recipes are prepared, I will break out of this loop, right? And this is the worst case. Like if I don't have any recipe left, I will not be here in this loop, right? So I'll break out of it, right? So this loop is also going to run for at max O of n times, that is 100. And in every iteration, we are going to perform 10 raised to power 6 work, right? So it would become, the total time will become 10 raised to power 6. It would become order of 10 raised to power 8, right? So the time complexity, if n is equal to 100, is O of order of n raised to power 4. Now we know that in like a computer in 1 second can only perform 10 raised to power 8 operations, right? So here also we are needing 10 raised to power 8 operations. So it is so and so, right? It is so and so. It can it will obviously fail because the number is not exactly 10 raised to power 8. We just say that these operations are constant time operations, but actually in the in the, if you look from the perspective of computer architecture, they're not constant time. There are multiple operations, like for this, or for this, even this, there are multiple operations in assembly, right? So this is not exactly O of 1. So that's why this solution is giving you TLE, because it is becoming exactly n raised to power 4, that is 10 raised to power 8. And the computer cannot exactly perform 10 raised to power 8 operation, it performs less than that. So yeah, that's why it is becoming TLE. But when I put here this reference, right, then factor of 10 gets reduced because I'm not copying it here, right? So new will be O of 100 into 10, which is O of 10 raised to power 5. Same thing here will become, a factor of 10 will be reduced. So it would become 100 into 10 raised to power, this would be 10 raised to power 3 into 10 raised to power 3 O of 10 raised to power 5. And same thing will become here, O of 100 into 10 raised to power 5 equal to O of 10 raised to power 7. And this will pass, like 10 raised to power 7 operations, this can pass the time limit. And that is why this solution is working, just because of this reference variable, just because of this reference, right? So you can see like how important correct analysis is for a problem. Just because of this analysis I was able to reach this conclusion, otherwise I would not have been able to reach this. Okay, so I hope this question is clear, but I understand this was purely implementation based problem and the time limit was very very tight. So okay, no problem. So I hope I was clear. If I was not, and like you are not able to understand something, then please comment it out. I'll surely help you. And if you're new to the channel, please like and subscribe the channel. And do let us know, like, if there is any topic that you want to learn from us, or if there is any problem for which you want us to make the editorial. We'll surely do that. All right. uh, Take care. See you. Bye.